Hello, Dr. Posey. Welcome back to the David Show. And today we're going to be talking about developmental theory, and the only room I can find to do this in is the prayer chapel. So I hope I'm not being sacrilegious. Just to start off, here we go. This is the comic. We have three characters. We have Dr. Dobson over here, and the other two characters are unnamed, but we'll get to them. Good evening, class. My name is Dr. Dobson. Today we'll be talking about developmental theory. He has his nice little MRI machine where they'll be viewing a child's brain, and they'll be talking about Piaget's theory of cognitive development. The basic premise is that a child creates mental models in order to understand the world around them. He developed this idea while doing work he called genetic epistemology. In other words, the blueprint for intelligence. That's what that term means, because the work he was doing was studying how different people, specifically children, learned. These mental models are created using these building blocks, also known as schema, represented here. They're also known as units of knowledge. For example, a person might possess the schema for riding a bike, represented by this green cube, with training wheels. So that includes the pedaling, the steering, the spatial awareness necessary in order to ride the bike. Yet, they do not have balance. What they have with this green cube is what you would call a script, since it involves a sequence of learned skills. For example, writing is a mental script because holding the utensil, putting it to the paper, writing the different letters to form the words, to form sentences. It's a whole script, and they can be expanded upon. Like this blue schema here, which is for balancing without the use of training wheels on a bike in this case. How do children, and by extension adults, obtain new schema, you ask? Thank you for asking. It's a great question, John, says the brand new character, who's a newsroom person. Piaget believed that intellectual growth happened gradually through what he called assimilation and accommodation. Assimilation being the use of an existing schema to interact with a new situation. Accommodation is the adaptation of the existing schema to better deal with the new stimulus being provided. And then equilibrium is the state reached where a new schema is formed to properly deal with the new stimulus. That should say stimulus. So I am going to change that because I can. So, breaking that down really simply, you first have the stage where a new thing comes at you and it's very similar to an old thing. For example, when you're a little child and you see a hippo, you look at it and you say dog because you associate four legs with it being a dog. Or a very specific scenario that I know of in my field is there's a little kid who could count up to 3. But as soon as they hit 4, they didn't know what to do, so any number they didn't see, they said it was a 4, because they kept seeing an opened 4 and a closed 4, and they were confused and just thought that any number that's not 1, 2, or 3 happened to be 4. And that's where their schema was. They can go 1, 2, 3, and then anything else was 4, because that was the stimulation they were getting, and they were never taught that, and weren't giving the scaffolding for it. We'll get to that. So the next thing with that kid came accommodation, where he had to take his knowledge that 4 can be presented a bunch of different ways, but he had to adapt it and understand that there are really only 2 ways that you could see the number 4, and not everything else was a 4. So then he reached equilibrium, where a new schema existed, where he knew these are 4s, this is a 5, and so on. Another perfect example of this is when Mr. Newsroom person over here first discovered a computer mouse. I didn't know what to do with it. I then had to adapt to a new method of input for his magical computer device. Piaget boiled it down to his 4 stages of development. It will show how different ages progress. You first have 0 to 2 years, also known as the sensory motor stage, which is where the child develops object permanence, which is required of them to make a mental image of the object. So when an object's not in their sight, they still know it exists because they can mentally understand and mentally see that it's there. Second is 2 to 7 years, or the pre-operational stage, which is where a child is able to understand symbolism and connect the dots between symbols and meaning. For example, reading. The word bear, B-E-A-R, refers to the animal, which is a bear, and it's using that symbolism just in language in order to apply it to something that's physical, or even just aphorisms or sayings, understanding how those work. Third is the concrete operational stage, which is from 7 to 11 years, which is when the child logical thinking begins to manifest through their ability to solve problems mentally. A lot of the times for younger kids, with all the nieces and nephews I have, the younger ones, they have to visually see everything in order to solve it. But as they get older and as they get more developed, I have a 5-year-old niece who has amazing mental acuity and just mental problem solving beyond her years, because that's just who she is. But at this stage, which is typically between 7 and 11 years, they can think of a problem or be presented with a problem just verbally or written on paper and be able to mentally figure it out instead of having to write it all out or physically move things around. So if you ask them, oh, how do you put these train tracks together? They don't have to sit there and test every single possibility. They can just mentally understand and think, oh, it should fit like this just from what I'm seeing or the stimulus I'm getting from it. Fourth and finally, we have the formal operational stage, which is typically found from 11 years to all the way up until adulthood, which is the stage of understanding abstract concepts and logically test ideas. So just like in science, it's being able to have a hypothesis and then figure out a way to test that and then continually test it, and just understanding concepts like an abstract concept being gravity, understanding how it works within space-time and that whole deal. I'm not going to go into it. Magical computer device man over here shows up into the doctor's office. With all that being said, these ideas lead to what we call discovery learning, meaning that students learn best through doing an activity and actively exploring a concept. So it's not just telling them this is the way it works, but they learn through doing. And as things move on, they're able to grasp things easier. And when they learn it through doing, it retains a lot stronger. What about the zone of proximal development? Says Mrs. Nesbit over here. The zone of what? I don't think we know this one, Julia. Well, then I'll take it from here. The zone of proximal development describes the difference between a learner's ability without help and their ability with help. As a visual, the yellow is what a child can do alone, and the gray is what they can achieve with guidance. This guidance comes in the form of scaffolding, a term introduced by Wood. Scaffolding is akin to training wheels on a bike, allowing the student to learn with help and then eventually master the concept at hand. This help comes from an outside source, like a teacher, called a more knowledgeable other. This other is not only able to help, but able to identify what a student can and cannot do, because it's important as an instructor to not only be able to answer questions someone might have, but to be able to identify their struggle points so you can focus on those in your instruction. What is needed is effective scaffolding. This consists of upkeeping a student's interest, breaking the task down or simplifying it to make it easier to understand, focusing on the specifics of what needs to be done and what they need to work on as a student, managing their frustration, which is huge, especially when working with kids, and demonstrating the task at hand. This is why a teacher is so important in how a student learns, since these students learn knowledge through social interaction. A lot of what Wood was talking about was how it is most of the learning that gets done is through the social interaction that someone might have. We are social creatures. We learn socially. In other words, a student learns from the more knowledgeable other. Now, these theories come from a man named Vygotsky. Excuse me, I said Wood, I meant to say Vygotsky, but it's a lot harder to remember. From the latter half of the 20th century, around 1970s, 1980s. For a practical application of his theories, we can look at something called reciprocal teaching, which is when an instructor allows students to take an active role in learning from a reading. So this is done a lot in elementary school or high school English classes, where you encourage the student to summarize, predict, ask questions, and really engage with the text at hand instead of just passively listening to it, as said down here. His ideas also contributed to the idea of collaborative learning, which is defined by having students learn in group settings. So you put students who are really good at something with students who aren't so good at something, so that the students who are good at it can bring the students who aren't so good up, because they're not just learning from an instructor, but they're learning from a peer. And a lot of times, as I've discovered, the peer can put it in words that the person who doesn't quite get it yet can understand a lot better than we can as adults, since we're a lot more separated from them. In conclusion, the cognitive development theory deals with PH ideas that learning is done in stages, with schema and stages of development all factoring into each other. On the other hand, Vygotsky's theory describes how a student needs a knowledgeable other to help them tackle the different zones of development. So, as Julia Nesbitt says, we hope you've enjoyed your time with us. Tune in next time to learn more about developmental theory. Have a good day.